guys, welcome back to Wong Chemistry channel. For this video, we are going to discuss about Boyle's law. Let's start off straight away with what Boyle's law stated. Boyle's law stated that for a fixed amount of gas at a constant temperature, the volume is inversely proportional to the pressure. So, right now, we have two variables that remain constant. The one that remains constant is the amount of gas. And the amount of gas that we mean over here is the number of mole of the gas. Alright? The second thing that remains constant in Boyle's law is the temperature. The temperature in the Boyle's law must remain constant. If the number of mole and the temperature remain constant, what is changing? The things that will be changing in your Boyle's law is definitely the volume and the pressure. So you have your volume and your pressure is changing. And they are changing in the relationship of inversely proportional. In the other words, when the volume increases, the pressure will decrease. And that is what Boyle's law said. You have two things that remain constant, the number of mole and the temperature. And you have two things that will be changing, which is your volume and pressure, inversely proportional. So, I have two conditions over here. Let's say that is my P1, that is my P2. By looking at the diagram, which one do you think have a higher pressure? Obviously, your P2 pressure is higher. How do I know that the pressure is higher? Looking at the volume, guys. Looking at this volume. The volume over here is smaller. When the volume is smaller, it means that our pressure is higher. Vice versa, your P1 over here is lower. The pressure that you have in your P1 is lower. Why the pressure is lower? Simple. Look at the volume again. Can you look at the volume? This is the volume that you have for the container, for your gas particles. So the volume over here is bigger. When the volume is bigger, means that your volume right now is higher. When the volume is higher, your pressure will be lower. Okay? And you can see that very clearly over here. When you apply pressure and you press something, the volume will definitely decrease. Okay? And that is how it works. Okay? And since we agree that your volume right now is inversely proportional to the gas, so you have your V inversely proportional with your pressure, looking like this. And why the formula of Boyle's law looks something like this? Simple. You are going to cross them. You are going to multiply them and cross them like this. So you will have your PV equals to K. K is a constant that you can ignore. Alright, K is a constant that you can ignore. So when you multiply them cross like that, you realize that your pressure will multiply by the volume. So you have your PV. That's why when you have your P1 V1 equals to K, the constant, and you have your second situation P2 V2 equals to K. And when you combine two of this, then you will get your P1 V1 equals to P2 V2. And this is the formula that we are going to use for the Boyle's law. Alright? Knowing that the P1 and P2 over here both are pressure. And knowing that the pressure having a lot of different units. So what unit are we using? You can use any unit that you want with one condition. The unit must be the same when you put into the formula. You can use your ATM. You can use your torr, you can use your millimeter mercury. It doesn't matter what you use, but the unit that you put into the formula must be the same. Alright? Next, you have your V1, V2. Your V1, V2 over here, guys, obviously is your volume. Your volume also must have the same unit. The volume unit is much simpler. You will normally have liter or milliliter. You can use either liter or milliliter, but the unit must be the same when you put them into the same formula. So in the other words, there is not much of the unit restriction. But what important is the unit must be the same when you put them into the formula. Alright? Next, we have 3 graphs for Boyle's law. So, the first graph is your pressure versus volume. We know that your pressure will be inversely proportional with the volume. So, you know that in here, your pressure is very high. That's why your volume is very low. While in here, your volume is very high. Therefore, your pressure is very low. Right? That is your pressure inversely proportional with volume. But what happens if I write volume inversely proportional with pressure? It's the same. You are going to have the same graph, but the axis will be inverted. But the shape of the curve will be the same. That is your volume versus pressure is the same. They are exactly the same. Alright? The second graph that you have over here is actually your pressure directly proportional with 1 over V. So when I say pressure directly proportional with 1 over V, that also represent by this. Can you see that? They are actually the same. Agree? And when you cross them, remember you multiple and you cross them, you will have your PV equals to K. And what we are trying to sketch over here is the graph of Y equals to MX. Can you see that? So, how to get the Y equals to MX? Easy. You move your V over. You will have your K 1 over V. And that is your Y equals to MX. Showing clearly that your Y, which is a pressure, and your X, which is a 1 over V, 1 over volume. Therefore, your M over here is your constant K. Alright? So, both of the graph is coming from the same relationship where pressure is inversely proportional with the volume. Just the way that you plot the graph is different because the axis is different. Okay? And last but not least over here is simple. Your axis is a PV versus pressure. So you have your pressure times volume versus pressure. The same thing, guys. It's definitely from the same relationship. So you have your PV equals to K. So your PV over here is actually equals to constant, your K. Right? So no matter how high your pressure increase, your volume will decrease. So we will form a constant graph. So all this graph for the Boyle's law coming from the same relationship of the Boyle's law. Okay? And the only things that are changing obviously is the axis of the graph and the shape of the graph. So be very careful with the y-axis and the x-axis if the question are giving you the graph. Okay? And last but not least, before we go into calculation, how do we explain Boyle's law by using kinetic molecular theory? We agree on when the volume of the container decrease. Looking at this is the volume of my container. Volume over here is extremely high or is higher. Okay? So volume is high over here. Moving downwards over here, you can see your volume is lower. When the volume decrease over here, what happened? The number of molecule per unit volume increase. And you can see that the molecule that you have over here is closer to each other. Why is closer to each other? Because the number of molecule per unit volume increase. Okay? When the number of molecule per unit volume increase, what can we observe over here is molecule of the gas are closer to each other. So when the molecule of the gas are closer to each other, the frequency of the collision between the gas particles and also between the gas particles and the wall of the container will increase. The collision will definitely increase because everything is closer. The probability of the gas molecule to collide will definitely be higher. And when the collision frequency increase, guys, the pressure will definitely increase. So you can see over here, when the volume decrease, when the volume decreases, the pressure will definitely increase because of the things that we have just discussed. When the volume decreases, the number of molecule per unit volume increase. In the other words, the gas molecule become closer to each other. Therefore, the frequency of the collision will increase. When we collide, we produce pressure. So when the frequency of the collision increase, no matter between the gas particles or the wall of the container, definitely produce pressure. Therefore, pressure will then increase. Simple? Easy. So we are coming to the conclusion of when the volume decrease, your pressure increase. And that is how we explain Boyle's law using kinetic molecular theory. Okay? So let's try the first example. A sample of a gas in a balloon is expanded from a 2.75 liter to 6.83 liter, which means the volume of the balloon right now become bigger. Okay? At 300 Kelvin. If the initial pressure before the expansion is 0.87 atm, be careful with the unit. That means the new pressure after the balloon expanded. So, the first thing that I will do is I will differentiate them into their P1 V1 and also their P2 V2. That is the most important thing because you want to find the correct pairing. Okay? So, let's say this 2.75 is the volume 1 and this 6.83 liter is the volume 2. Okay? So, you have your volume 1 over here, 2.75 liter. Your volume 2 over here is 6.83 liter. Done for the volume. If the initial pressure before the expansion means is the first situation. That is your P1. Okay? So, your P1 over here is 0.87 atm. Okay, before it's expand means we are right now at the smaller scale, smaller size. So the pressure at the V1 is 0.87 atm. The question definitely asking for the P2, which is the new pressure after the balloon expanded. Okay, before I answer the question, you need to know the unit. You need to check the unit. So make sure the volume right now both are in the correct unit, liter. And your pressure P1 given is in atm. So when you calculate your P2 from this unit, your P2 will straight away also be in atm. Because you are calculating the pressure from the unit atm. Okay? We agree on the unit must be the same. So the next thing, definitely the formula. P1 V1 equals to P2 V2. Make sure you substitute in the correct pairing. P1, 0.87 atm. Your V1, 2.75. And your P2 is the one that we are looking for. Your V2 is the one given, 6.83 liter. And when you press your calculator, you realize that your P2 must be lower than the P1. Why do I know that? Simple. Because your V2 over here is bigger than your V1. Your volume increases. Your balloon expanded. When your balloon expanded, it means the pressure decreased. So your P2 over here must decrease compared to your P1. Therefore, your P2 calculated is 0.3503 atm. Make sure your final answer comes with the correct unit. Alright? Simple. Next, your second example. You have 100 ml gas in a can. Alright? That the pressure is 103 kilopascal at room temperature. If the gas in the aerosol left is 43 milliliter, find the new pressure. Simple. This is even easier because they already give you in a pairing. If this is my V1, that will be my P1. So if this is my V2, I'm looking for the P2. As always, we will take it out first. My V1 over here is 100 milliliter. my P1 over here is 103 kilopascal. And then you have your V2. Our V2 is 43 milliliter. Our P2 is the one that we are looking for. Same thing, before we proceed, check the unit. Make sure the volume, both are in the same unit. And the pressure given is in kilopascal. In the other words, when I calculate my P2 will also be in kilopascal. See that? Simple. And what do you think the P2 will be? Whether it's higher or lower than the P1. Looking at the volume, your V2 over here, alright, is 43. Your V1 is 100 milliliter. And from there, you can see your V2 is smaller than your V1. Why your V2 can be smaller than your V1? Because your P2 is higher than your P1. Okay? So the P2 calculated must be larger than 103 kilopascal. Let's see. You have your P1 V1 equals to P2 V2. Make sure the pairing is correct. Once again, pressure 103 kilopascal, volume 100 milliliter. Your pressure over here, again, we are looking for the P2. Your volume 2 is your 43 milliliter. And when you press your calculator, your P2 calculated must be larger than 103 kilopascal, which calculated to be 239.53 kilopascal. So this is the pressure when the gas left with 43 milliliter. Okay? That is the new pressure because the volume decreased. Make sense? Simple. Next and last but not least, your example 3. We have a gas bubble at 15 meter under the sea. So I have a sea over here. Alright, that is our sea level. And it's 15 meter under the sea. And the air bubble rises from the bottom of the sea to the surface of the sea. Okay? And as the bubble rises, the pressure decreases from 3.75 atm to 1 atm. Which means the 3.75 atm is at the bottom of the sea. The 1 atm is at the surface of the sea. Okay? Because when the air bubble rises, when the air bubble moving up to the surface, the pressure decreases. So 3.75 atm is at the bottom of the sea. 1 atm is at the surface of the sea. Okay? The air bubble measured at the surface is 0.086 liter. So at the surface, the bubble having this volume at this pressure. So the question is asking, determine the size of the air bubble 15 meter under the sea. So I'm looking for this volume. And that is what the question about. So pair them up. Let's say I have my P1 V1 is the one on the surface. That is my P1, that is my V1. My P1 is a 1 atm. My V1 over here, 0.086 liter. Therefore, this one will straight away be my P2 and this will be my V2. My P2 given in the question, 3.75 at the bottom of the sea. Your V2 is the one that we are looking right now. And before we do anything, always check the unit. You have your ATM for pressure, you have your ATM for pressure. Done. Check. Your volume is in liter for the V1. Therefore, when you use the formula to calculate the V2, your volume 2 must be also in liter. Make sure you cross-check the unit. Okay? So you have the formula of P1 V1 equals to P2 V2. And your P1 over here is a 1 atm. Your V1, 0.086 liter. Your P2 given 3.75 atm. Looking for the V2. So the V2 calculated over here will be smaller or bigger than V1. Let's see. It's a 0.023 liter. That is the volume that you calculated. Why the volume right now is smaller? The volume of your V2 is smaller than your V1 because the pressure over here is higher than the P1. When the pressure of your P2 is higher, automatically the volume will decrease. And that is what Boyle's law trying to tell you. When the pressure increase, the volume decrease. Okay? As simple as that. The calculation of Boyle's law is extremely simple. P1V1 equals to P2V2. But just be very careful with the unit. Make sure the unit of the pressure of P1 and P2 must be the same. The unit of the V1 and V2 must be the same. Alright? And that's it for Boyle's law. If you still have any question about Boyle's law, drop it in the comment and I'll get back to you as soon as I can. Make sure you like the video and subscribe to my channel. And thank you for watching, and I'll see you again in the next video.
TunePocket.com